This tutorial will explain how PROFIS Anchor performs seismic calculations using the provisions of ACI 31808 and the IBC 2009 Building Code. ACI 31808 Part D.3.3 contains provisions for seismic design of anchorages into concrete. Seismic design provisions are used when designing anchorages that include earthquake forces for structures assigned to seismic design category C through F. PROFIS Anchor users can select seismic design per the provisions of D.3.3 by clicking on the Loads tab, then clicking on the box titled Seismic Design. When seismic design is selected, three options become available. The first option is design per the provisions of D.3.3.4. The second option is design per the provisions of D.3.3.5. And the third option is design per the provisions of D.3.3.6. Part D.3.3.2 states that post-installed structural anchors shall be qualified for use in cracked concrete and shall have passed the simulated seismic tests in accordance with the test standard known as ACI 355.2. When seismic design is selected as an option, PROFIS Anchor will perform calculations for both cast-in-place anchors as well as Hilti post-installed anchors. PROFIS Anchor will only perform seismic calculations for post-installed anchors that have been qualified in cracked concrete for seismic conditions per the provisions of ACI 355.2. These anchors can subsequently be used for seismic design in either cracked or uncracked concrete conditions. Let's illustrate how PROFIS Anchor performs filtering for post-installed anchors not qualified per the provisions of D.3.3.2. The Quick Bolt 3 anchor has been qualified for use in uncracked concrete non-seismic load conditions. The Quick Bolt TZ anchor has been qualified for use in both cracked and uncracked concrete, seismic and non-seismic load conditions. When seismic design is selected as an option, PROFIS Anchor will filter out those anchors that have not been qualified per the provisions of D.3.3.2. Therefore, note now that only the Quick Bolt TZ anchor remains as an anchoring option when we've selected seismic. Part D.3.3.3 states that a factor of 0.75 will be applied to design tension strengths and design shear strengths. PROFIS Anchor will apply a factor of 0.75 to all non-steel design strengths, including bond strength, when seismic design is selected as an option. The 0.75 factor will be designated by PROFIS Anchor as phi seismic. The PROFIS Anchor design report will show the 0.75 factor noted in D.3.3.3 as phi seismic. Note once again that phi seismic is not applied to any design steel strength. However, phi seismic will be applied to all non-steel design strengths such as concrete breakout. Selection of D.3.3.4 as a seismic option requires the connection design to be governed by the steel strength of a ductile steel element, in accordance with the provisions of D.5.1 for tension and D.6.1 for shear. ACI 31808 Part D.1 defines a ductile anchor element as one which has a tensile elongation of at least 14% and a reduction in cross-sectional area of at least 30%. When PROFIS Anchor users select seismic design as an option, the program will default to the provisions of D.3.3.4. All of the cast-in-place anchors in the PROFIS Anchor portfolio are considered ductile steel elements. When post-installed anchors are selected as a design option, PROFIS Anchor will filter out any post-installed anchor which is not by definition ductile. Therefore, the portfolio that becomes available will include only those anchor elements which are by definition ductile per the provisions of Part D.1. When D.3.3.4 is selected as a design option, the designed steel strength of a ductile steel element must be the controlling design strength for the application. The PROFIS Anchor design report indicates the controlling design strength via the percent utilization. Percent utilization corresponds to the factored load divided by the design strength. The design strength having the highest percent utilization corresponds to the controlling design strength for the application. In the top half of the screen, D.3.3.4 has been selected, and the design steel strength has the highest percent utilization. Therefore, the design steel strength is the controlling design strength for this application, and the provisions of D.3.3.4 have been satisfied. In the bottom half of the screen, you can see the concrete breakout strength has the highest percent utilization. The provisions of D.3.3.4 have not been satisfied because the design steel strength is not the controlling design strength for the application. Therefore, the design report will indicate that the fastening does not meet the design criteria because the provisions of D.3.3.4 have not been satisfied. Part D.3.3.5 offers an alternative to the ductile steel element provisions of D.3.3.4. It permits the attachment that the anchor is connecting to the structure to be designed so that it undergoes ductile yielding at a force level which is less than or equal to the design strengths calculated per the provisions of D.3.3.3. When D.3.3.5 is selected as an option, a pop-up will appear asking the user if they would like to re-input loads corresponding to yielding of the attachment. If no is selected, then no load modification will be made. If yes is selected, then the loads can be modified accordingly. Part D.3.3.6 offers an alternative to the ductility requirements of D.3.3.4 and D.3.3.5. It requires an additional reduction to be applied to the design strengths that are calculated per the provisions of D.3.3.3. Selection of D.3.3.6 as a design option permits design for non-ductile failure modes. A reduction factor will be applied to the calculated design strengths for all non-ductile failure modes in both tension and shear. This reduction is applied to all non-steel design strengths as well as to steel design strengths corresponding to anchor elements that are by definition non-ductile. PROFIS Anchor designates the reduction factor that is applied as phi non-ductile. Users can input values for phi non-ductile ranging from the default value of 0.4, which is given in ACI 318, to any value up to and including 1. IBC 2009 contains seismic provisions for anchorage of non-structural components and anchors designed to resist wall out-of-plane forces. Part 1908.1.9 waives the ductility requirements of ACI 318.08 Part D.3.3.4 and D.3.3.5 when the anchorage includes design for non-structural components or anchors designed to resist wall out-of-plane forces. When anchor design includes the provisions of IBC 2009 Part 1908.1.9, PROFIS Anchor users can input a value for phi non-ductile equal to 1. This will permit an anchor design that includes both ductile and non-ductile anchor elements for non-structural components or anchors designed to resist wall out-of-plane forces. If you have technical questions or you'd like to receive additional technical information, click on the wrench icon at the upper left portion of the main screen. Then select the Resources option and select the option to contact us. Your email will be sent to Hilti North America Technical Services. This concludes the tutorial explaining PROFIS Anchor calculations using the seismic provisions of ACI 31808 and IBC 2009.